Ladies and gentlemen, would you look at this? We are now in lesson 17 of Unit 8, our very last lesson, not only of the unit, but of the entire school year. We've made it. Congratulations, our very last lesson. This is a really good one, actually. I really like box whisker plots. I hope you do too. We're going to practice more with those today. Get to know, not only review how to make them, but also learn how do we use them and what are they good for and how can they help us understand our data sets even better than we already do. So let's dive into this last lesson of the year. Holy cow. Activity number 1 is all about hours of slumber or hours of sleep at night. Let's read what this is all about. It says 10 6th grade students were asked how much sleep in hours they usually get on a school night. Here is the 5-number summary. Okay, so this is the big 5, right? The big 5 important bits of information from the data that was collected. So knowing these 5 things, number 1 asks us to draw a box plot or a box whisker plot of this 5-number summary. They give us a grid and a nice number line to work from, so that's super handy. Let's dive right in. Our minimum is at 5 hours. So at 5 hours, I'm going to go up and I'm going to draw just a straight, nice, thick line so I can see it over the grid. Okay, so there's my minimum at 5, and I'm going to label that. I'm going to write min right above there. And I have a feeling this is going to be a small little guy, so we got to be careful to write small. Okay, so our minimum is on there. Let's go ahead and do our maximum next, right? Our maximum is over at 9. So now see how small this box is really going to be. Our maximum is only here at 9. Holy cow, that's as big as our dot plot or our box plot. See how easy it is to say those? Our box plot is only going to be that big total. Well, this is our maximum at 9. Holy cow, this is going to be small. Now, in the middle, right? I like to go to the middle next at 7.5 hours. That's going to be the middle of our box. So 7.5 hours is halfway between 7 and 8. So right in here is where our box is going to be. And I'm going to make it slightly bigger than the grid marks. I need my nice thick side of my lead here. There's my Q2, my median, right, is right at 7.5 hours. Now I need my first quartile. My first quartile is at 7. So right here on the grid marks itself is a nice thick line. That's going to be the left side of my box. And that is where my left whisker will extend to from the minimum to the left side of the box. So there's my first quartile. Oh, I already did that as well. Now all I need is my third quartile, which is at 8. So straight up from 8, I'm going to do another nice thick line. That's going to be the right-hand side of my box. Again, that should be one continuous box. Right, oh, so I need to label Q1 really small over there and Q3 over there. Yeah, see, this gets kind of, maybe we won't worry about the labels because this is such a squishy little box plot that it's almost easier to understand it without the labels than with the labels, right? There's our box plot. We've got our third quartile at 8, our median at 7.5, our lower quartile or our first quartile at 7, our left whisker going from there all the way to our minimum at 5, our right whisker is going from our upper quartile over to our maximum at 9. So there's our box plot for number 1. We are done for number 1. Number 2, I like this question because it makes us think ahead of time. What questions, if I was the teacher, what questions could be answered by simply looking at the box plot? So let's say I didn't know any of this. What could I ask just looking at this? Well, I could ask what all these are because I can see them, can't I? So that's the first thing. I can identify the big 5, right? I could actually ask my students, you know, oops, I don't need that. What is the minimum? What is the maximum? What is the median, right? And all of those big 5 things can easily be identified on the box whisker plot. But what else could we ask? Well, we could ask more in depth, like not just what is the maximum, but we could say, what is the biggest number of hours of sleep, the most hours of sleep that a student got, right? And that would be 9 hours. What is the least number of hours a student got? That would be 5. So you can expand it into more wordy kind of word questions, identifying those parts as well. But remember, there's a lot more to a box whisker plot because of the fact that it's split into 4 equal parts, right? We could say, how many students read fewer, not read, slept, I was thinking of a different problem, slept fewer than, say, 7 hours. Well, if I know that there were 10 students, then a fourth of 10, or 10 divided by 4, would be 2.5. Well, 2.5 students, that's tricky. But we know at least 2 students read fewer, maybe it's 3 students read fewer than 7, or slept fewer than 7 hours. We also know that the same number of students slept more than 8 hours, between 8 and 9 hours, right? Because that is also a fourth of the data. We know that half the data, or 5 students, slept between 7 and 8 hours, right? Somewhere between 7 and 8 hours is half of the data, right? So fewer than 7 or more than 8 or between such and such and such and such. There are so many questions that we could answer according to this box plot. It's kind of cool to think about, what could I answer? What kind of things might the teacher ask me? And could I do that with the box whisker plot, right? Super, super great. Let's dive into the next activity. Actually, here's the thing. We are actually not going to do the next activity. Activity 17.2 is one of those info gaps where one of you gets a problem card and one of you gets a data card. Well, that's really hard to do from home, so we're not going to do this activity. It's just practicing identifying those parts on a box whisker plot, which I think we've gotten pretty good at. So we're going to dive straight into activity 17.3 today, which is all about paper airplanes. I don't know about you, but when I was a kid, I had 3 older brothers. So we would make paper airplanes all the time because they got really into that. In fact, they would make model airplanes too, because they just enjoyed that. So playing with brothers, I got into that as well. So this is kind of fun for me. It's a little reminiscent of my childhood. It says, Andre, Lynn, and Noah each designed and built a paper airplane. They launched each plane several times and recorded the distance of each flight in yards. So at first when I read this, I didn't realize it was in yards and I thought it was in feet. And I was pretty impressed that they went 30 feet. But to know they went 30 yards, that's even more impressive. These must have been really, really well-made paper airplanes. I know my paper airplanes never went 30 yards. That's crazy. That's awesome. So looking at our data, we've got 3 rows of data. Andre's data goes across here, Lynn's data goes across here, and Noah's data goes across here. And notice they're already in order for us. So that's super nice of our workbook for putting those in order for us. I love it when they do that. Okay, so just taking some time to notice those kinds of things will speed things along greatly for us. Let's go into our first prompt here. Of course, we can't work with a group. We're just going to work together on these. It says, write a 5-number summary for the data for each airplane, then calculate the interquartile range of each data set. And as you can see, I need to find the minimum for all 3 airplanes, right? The first quartile for all 3, the median for all 3, etc., including the interquartile range for all 3. So we're going to have to fill out this table together. So in order to do that, we need to start working with this data, don't we? The easiest things to find, of course, are the minimums and the maximums. So let's start there. What's Andre's minimum? Well, his was 25. What's Lynn's minimum? 20. And what's Noah's minimum? 13. Awesome. Those three are done. Now let's go over here to the maximum. What is Andre's maximum? It's all the way over here at 30. What is Lynn's maximum? 32. Wow, even bigger. And Noah's maximum is 25. Awesome. Okay. Now we need to find, what's the next thing we can find? Knowing the minimum and the maximum and our data values. The next thing we need to find, of course, is the middle, the median, right? We do that by finger squeezing. We know how to do that. Pretty straightforward. So let's do it for Andre first. We're going to do one box at a time as we're finger squeezing towards the center. And in this case, there is a perfect center, and it happens to be 28. I'm going to keep my finger on that 28 because you know what? Isn't that going to be the middle of all three rows? Super great. That's the median for all three. So 28 is Andre's middle. Lynn's is also 28. That's interesting. And Noah's is 20. Kind of handy when they're organized in a table like that, isn't it? Now we need to find the first quartile, which is the middle of the bottom half, right? So we've got 1, 2, 3, 4, 5 data values. So here's the middle, right? 2 on the left, 2 on the right. We didn't even need to finger squeeze that. We can almost just visualize it with our eyeballs, can't we? So 27, here's our, oh, I should label these. This is the median, right? Those were the medians. And now here's our Q1s, right? So Andre's Q1 is 27. Lynn's Q1 is 21. And Noah's Q1 is 15. Okay, so there's the first quartiles. Now we need to do the same thing for the third quartiles over here. So once again, we're only going to look at the right-hand side of the data. But once again, of course, we have 1, 2, 3, 4, 5 data values. So there is a middle value. So here's Q3 right here. Right? Oh, my circles are sloppy today. So there's our 3 Q3s. Let's put them in here. Andre's is 29. Lynn's is 29. And Noah's is 23. Awesome. So now that we have these all filled out, there's our big 5 for all 3 airplanes. Now I need to find the interquartile range. And if you remember, the interquartile range is Q3 minus Q1. So this quartile minus the upper quartile minus the lower quartile. So we could either do it here or we could do it here, couldn't we? 29 minus 27 is 2, right? 29 minus 21 is 8. And 23 minus 15, 23 minus 15 is also 8. There, done with number 1. Okay? So we have found all 5 of the big 5 values, and then we also calculated the interquartile range for all 3 paper airplanes. Okay, done with number 1. Now we're ready for number 2. Now it's time to draw a box plot for each of the airplanes and label the box plots carefully. Now, at first I thought, oh man, I'm going to have to draw myself a grid and a number line and all this. But as you probably see in your workbook, they gave one to us, didn't they? And I just didn't realize it till they flipped the page. So let's use this one they gave us. I'm going to get the number line out of, or the name line out of my way here. Once again, I hate that they put a name line on every page. I'm going to get that out of my way. We're going to use this little grid that they gave us to draw 3 box plots all on one grid. We're just going to stack them on top of each other. Okay? So, because we're going to be stacking these one on top of each other, and I kind of want them in the same order, I'm actually going to start with Noah and do his nice and close to the line here. And then I'll do Lynn's right above that, and then I'll do Andre's right on top of that. Does that kind of make sense to everybody so that we use our space wisely? Okay, so let's start with Noah. His minimum is at 13, so I'm going to find 13. Let's see, this is 15, 20, 25, 30, 35, 14, 13, 12, 11, 10. Yep, so 10 is right on the edge there. Okay, I just wanted to make sure that this grid matched up better than yesterday's grid. Remember when that one didn't line up very well? But this one seems to be lining up much better. So let's go ahead and start. Noah is where we're going to begin. His minimum was at 13. So 10, 11, 12, 13. So I'm going to go up to about right here. I don't want to go up too far and get in the way of, I need room for everybody, right? So there's his minimum. Then his whisker is going to extend all the way to Q1, which is at 15. So I'm going to make that a little bit taller than the bottom one, and I'm going to put that whisker in there. Okay, so there's my lower quartile. Then my median is at 20. Remember, that's going to be the line that's in the middle of the box. That's at 20. And I could connect that now if I wanted to, or I could connect it with the upper quartile in a bit, which I think is what I'm going to do. Let's go to 23, 21, 22, 23 is where my upper quartile is. Now I can connect all of those with one solid line as my box. So I've got my box, part of my box plot drawn now. Okay. Now that was upper quartile, so now I need my maximum. My maximum is at 25. So I'm going to do a little line there, and that's my right-hand whisker. Okay. Okay, so 1, 2, 3, 4, 5 data values. There's my box whisker plot. Now, the only thing I forgot to do is label this as Noah's. So out here to the side, I'm going to write Noah to label that box plot as Noah's box plot. Okay, now we're ready to go on to Lynn's, and we're just going to stack Lynn's slightly up from Noah's. Okay, Lynn's minimum is at 20, so hers actually starts clear over here at 20. So again, I'm going to go up a little ways from, I don't know how much room I'm going to have. I guess I'm going to have to go about right here. I want plenty of room. I might be able to go up one. Maybe I'll go up one more. I don't want them too squishy, but I don't want them too spaced out because I want to have plenty of room. I might be right at the upper line for my third one, but I think this will be okay. Okay, so there's Lynn's minimum at 20. Oh, I should label this as Lynn now. Okay, so there's Lynn's minimum. And then her first quartile is right next door at 21. So I'm going to make that slightly taller, but right there. And there's my left-hand whisker. Her median is at 28. So here's 25, 26, 27, 28. So I'm going to go up from there. There's her median. This is going to be a little too squishy. I might need to scoot this down. I think I made this too high. So let's move, sorry Lynn, we're going to have to move you down a little bit. There. We're going to move her down to here. Okay. I'll move her label down as well. Okay. There's Lynn's beginnings. So we've got minimum, first quartile, and median. Okay. Now her upper quartile is at 29. So right next door is her upper quartile. Now that turns into our box. Okay, so there's her box at 29. And then her maximum is at 32. So there's 30, 31, 32 is her maximum. So that's where the whisker is going to go. So there's Lynn's box plot. Wow, it's quite different than Noah's was, isn't it? Very good. But there's Lynn's. Now, we do have plenty of room now for Andre's. I'm certainly glad I scooted that down, though, so it wasn't too squishy. Andre's, here we go. Andre's minimum is at 25. Wow. So his minimum starts clear up here at 25. Okay, and then his first quartile is at 27. So 25, 26, 27. There's his first quartile, so that's where his whisker goes. Median is at 28, so right next door at 28. Okay, His third quartile is at 29, so once again, right next door. So he's got a very small box, doesn't he? So we'll finish that box. Look at that, 27, 28, 29 is the smallest box we've had. And then his maximum is at 30. So that's actually right next door as well. So his little box whisker plot up there, I gotta label this one. Andre's box plot is kind of small, isn't it? Awesome. All right, we have all 3 box plots done. Now, the last thing we could do, just to double check, we know the IQRs, right? Let's double check them. Is my Andre box 2 units wide? 1, 2, yes, so that's right. Is Lynn's 8 wide? 1, 2, 3, 4, 5, 6, 7, 8. Yes, it is. And Noah's should also be 8. 1, 2, 3, 4, 5, 6, 7, 8. So another way to double check that you got everything drawn correctly is to use that IQR. So that's super great. So there we go. There's our box plots. We've got them. We've labeled them clearly with Andre, Lynn, and Noah. So we're done with number 2. Number 3. How are the results for Andre's and Lynn's planes the same? So if we go back, we can either look at the data or we can look at the dot plot. It doesn't really matter. How are they, Lynn's and Andre's? So we're comparing Lynn's and Andre's, so the top 2. How are they the same? Well, the only thing that I noticed that's the same is the median. And I noticed that along the way here when we did our data, right? They both have a median of 28. So that's what I'm going to write here. Both have a median of 28. And how are they different? Well, everything else is different, right? Really, the only, oh, you know what else is the same? The upper half of both of their boxes is only 1 unit. So that is kind of cool. Their third quartile is also the same. Both have a median of 28 and a Q3 of 29. See that? They both have the same median and the same upper quartile. Okay, now other than that though, everything else is different. Everything else is different. Okay. In number 4, it asks us to compare Lynn and Noah. So now we're doing the bottom 2. Is there anything that's the same between Lynn and Noah? Well, looking at the box plot, Lynn's minimum is the same as Noah's median. Those aren't really the same, but I mean, that's kind of interesting, right? Let's look at their data. Is there anything between Lynn and Noah that's the same? Oh, there it is right there. And I remember that when we were counting the boxes, their IQRs are the same. So both have an IQR of 8. So that's the same. Is there anything else that's the same? We could say this thing that I noticed about Lynn's minimum is the same as Noah's median. That's kind of interesting. But other than that, they really don't have anything else the same, do they? So pretty much everything else is different. I am going to mention Lynn's minimum is the same as Noah's median, and it happens to be at 20, right? But everything else is different, right? Their whisker lengths are different, their boxes are different, their medians are different. I wonder about their ranges though, actually. Don't these kind of look to be the same length? Let's see about their overall range, not just their interquartile range, but their total range. This range would be 25 minus, we can do it on the data here. 25 minus 13 is 12. So I could write that down up here. So Noah's range is 12. What is Lynn's range? 32 minus, oh, look at that. Their range is also 12. 32 minus 20 is also 12. So there's something else that's the same. They both have a range of 12. So there's another thing for number 4 that they have in common. Okay? Very, very good. We are done, ladies and gentlemen, with lesson 17, which means we are done with our last lesson of the year. This Are You Ready for More is super great, though. It gives you a chance to practice drawing another bot plot for some data for Priya. So again, it's optional, but great practice. So I want you to give that a shot. And then don't forget to take a look at the summary page. This one's really great too. There's 2 really great examples, and it compares once again dot plots to the box whisker plots. And I love that it does that. So it's definitely worth your time, not only with this example, but there's a second example of ladybugs and beetles that I really enjoy as well. So reading through those summary examples is a great way to study for your Check Your Understanding quiz that's coming up, right? And for the unit test, frankly, that's coming up, right? If this is the last lesson of the unit, our test is right around the corner, isn't it? In fact, our test is when? Do you guys realize when it is? Our test is tomorrow. Okay, I won't sing. That's really bad. But it is. Our test for Unit 8 is tomorrow, Friday. So, yeah, I would encourage you to read through the summaries, not only for this lesson, but for all the lessons in Unit 8. Oh my gosh, Unit 8. We're in Unit 8. Read through those summaries. That's a great way to study for tomorrow's test. You know what's next, though? The only thing we have left to do is tonight's homework. The practice problems for lesson 17. There's only 4 problems tonight, ladies and gentlemen, and the first 2 are pretty straightforward. Actually, yeah, these won't take us very long, so let's dive into. There's only 4 questions. 2 of the 4 are multiple choice or select all, so that's going to be super fast. Read carefully, right? Don't rush through it. Read it carefully and get the right answers. Do that on your own first, and then we'll come back and check your work. I know that you've done a really, really great this far. Let's finish it off with a bang and get 100% on our last homework assignment. That's your challenge. Let's see if you can do it. Ready, set, go. Hey, ladies and gentlemen, one thing I just realized before you dive into your homework, we are not doing number 4. I just realized that it asks for something called the MAD or the MAD. That was one of the lessons we skipped. We did not learn how to find the MAD or the MAD, so skip that. Okay, we're not going to do number 4. So all you have to do in lesson 17 is problems 1, 2, and 3. Okay, good luck.
Do your best, because you deserve your best.
All right, let's go over our practice problems for lesson 17. Again, you only had to do 3 problems. Numbers 1, number 2, and number 3. We're skipping number 4. So let's dive into number 1 here real quick. Here are box plots that summarize the heights of 20 professional male athletes in basketball, football, hockey, and baseball. Wow. 4 box plots stacked on top of each other. I like it. Part A, in which 2 sports are the players' height distributions most alike? Explain your reasoning. So when we're looking at distribution, there's 2 different ways we could look at this, okay? We could look at it from the overall range, right? So if we're looking at the overall range of this data, which ones are the most alike? Well, none of them are exactly the same, as we can tell, right? Basketball's pretty wide, football is smaller, but second in line, and then this one's the next shortest and then the next shortest. But these two, I think, are the closest. So according to range, hockey and baseball would be the most alike. And also, the other way to look at distribution here is to look at the median, right? The center bar or center line in all of our boxes is the median. And if we compare the medians, the ones that are closest to each other, I believe are hockey and baseball as well. So putting those two ideas together, I think hockey and baseball are the most alike for problem part A. Okay, so I'm going to say hockey and baseball are most alike in median and overall range. Okay? Which sport shows greatest variability in players' heights? Okay, so for the greatest variability, this is where we definitely look at range, whether it's range overall or interquartile range. Those are the two things we kind of look for, right? Remember, variability is all about how spread out the data is, right? How widespread the data is. So if we're comparing the biggest variability, I think it's pretty obvious which one has the biggest overall range. Has to be basketball, right? So I'm going to say that one first. Basketball has the largest range, right? The second thing, like I said, that we look at for variability is that interquartile range. Because remember, that's half the data. That's the center half of the data. So if we compare the boxes, that's the interquartile range, right? Q1 from Q3. So if we look at the boxes, which one of the boxes has the biggest range? Well, I think football is slightly bigger than basketball. So in that case, football has the largest IQR. So overall, I think basketball has the most variability, but a close second would be football if you look at interquartile range, right? Because their middle half, right, has more variability than basketball's middle half, right? Yes, they've got some really, really tall dudes and some actually really short dudes, but most of their guys are right smack dab in the middle here, right? Where these guys are a little bit more varied, a little bit more variability in the football people, okay? But there is a second part of this question, part B. It says, which sport shows the least variability, okay? So on the other side of this, which one shows the least variability? Well, the smallest range would definitely be baseball. Baseball has the smallest range. Now, if we look at IQR, which one has the smallest IQR? Well, the smallest box is actually also baseball and IQR, right? So I think if we were to say the sport that shows the least variability, it would hands down be baseball, because it has the smallest range and the smallest IQR. So baseball's heights really don't vary very much at all, do they? They're all really close. In fact, if you think about it, this is height in inches. Between 70 and 71 inches, that's not much variety at all, right? 70 and 76 inches. Even so, that's not much. It's only a 6-inch difference really there. Where this one is a pretty wide difference, isn't it? Okay, good, good, good. Moving on to number 2. This is a select all problem. And we've got a box whisker plot to look at for this one. It says, here is a box plot that summarizes data for the time in minutes that a fire department took to respond to 100 emergency calls. Okay, select all the statements that are true according to this box plot. So we got to find all the statements that are absolutely true, knowing what we know from the box plot. Let's look at statement A. Most of the response times were under 13 minutes. Okay, so here's our time in minutes. Where's 13 minutes? Well, it's halfway between 12 and 14, which looks right to be our Q3, isn't it? So I'm going to label that on there so we can reference that. Our Q3 is 13 minutes, and it says most of the response times were under 13. So that would mean this way, right? Could we say that's true? Well, remember, a whisker is 1/4 of the data. The lower end of the box is 1/4 of the data. The upper end of the box is also 1/4 of the data. And the upper whisker is 1/4 of the data. So that would mean that under 13 would be 1, 2, 3/4 of the data. That is definitely most of the data, isn't it? So yes, I think A is true at 3/4 the data, right? Let's check statement B. Fewer than 30 of the response times were over 13 minutes. So here's our 13-minute mark. We know that 1/4 of the data were more than 13 minutes, but how much is 1/4 of the data? Well, our data had 100 people in it. So what is 1/4 of 100 people? I mean, not 100 people. Yeah, 100 calls. 100 calls. Well, 1/4 of 100, or 100 divided by 4, would be 25, right? So 25 calls were more than 13 minutes. And it said fewer than 30. So that's actually true, right? Because 25 is fewer than 30. So that is true, right? Because over 13 minutes was exactly 25 calls, wasn't it? Okay. Let's see if part C is also true. More than half of the response times were 11 minutes or greater. So let's find 11 minutes. That's going to be halfway between 10 and 12. So right in here. More than half. Well, if I go up to my graph here, that doesn't line up with any of my big 5. And if you remember, half would be from the median up. And that's not the median. The median's clear down here. So is this more than half or less than half? That would be less than half, wouldn't it? Because half would be here. So that's less than half. So that one is false. Okay. Part D, let's see if this one's true. There were more response times that were greater than 13 than those that were less than 9. Well, let's find 9. Oh, 9 is our median, isn't it? So 9 is our median. Q2 is 9. Okay, so were there more above 13 or below 9? Well, above 13 was 25. We already knew that. 1/4 of the data, right? So how many were below 9? Well, that's 1/4 for the lower box plus another 1/4 for the whisker. So that's actually half the data. That would be 50 calls. And it says there were more greater than 13. 25 is not more than 50, so that's also false. Does that make sense? 25 is not greater than 50. I'm going to rewrite that because I kind of messed that up a little bit. 25, there's the greater than symbol, and when you put a slash through that, it means not greater than. So 25 is not greater than 50. Okay, so that is not true. Part E, about 75% of response times were 13 minutes or less. Well, again, here's our 13 minutes at our Q3. We know that less than that is 1/4, 2/4, 3/4. Is 3/4 the same thing as 75%? It is, isn't it? Remember, each of these is a quartile or 25%. 25%, 25%, right? So each of these sections of our box whisker plot are 25%. So, yeah. 25, 50, 75%. So about 75% were less than 13. That is true. So E is true. So our answers to number 2 are A, B, and E. Okay? Last problem. Here we go. Problem number 3. This is another select all problem. This time we have 3 box whisker plots to look at. It says, pineapples were packed in 3 large crates. Crate 1, crate 2, crate 3. For each crate, the weight of every pineapple in the crate was recorded. Here are 3 box plots that summarize the weights in each crate. So here's all the weights in each crate. Each pineapple has been weighed in each crate, right? Select all of the statements that are true according to the box plots. All right, once again, let's see if A is true. The weights of the pineapples in crate 1 were the most variable. Remember what variability is, right? It's how spread out the data is. So does crate 1 have the most variability or the largest spread, right? Is that true? Well, look how wide 1 is. Is it bigger than 2? Yes, definitely bigger than 2. Is it bigger than 3? I think we can say yes, crate 1 has the widest spread, or in other words, the most variability. So yes, I believe A is true. Okay, let's go on to B. The heaviest pineapple was in crate 1. Well, how do I identify the heaviest pineapple? Well, the heaviest pineapple is the maximum, isn't it? So where are the maximums? Well, the maximums are at the far right-hand side of the whiskers. So the maximum of crate 1 is 6. The maximum of crate 2 is 3.5. And the maximum for crate 3 is 5. So which one has the greatest maximum? Crate 1. Yep, B is also true. Does that make sense? And you can tell that even without knowing the numbers. It's the furthest to the right of all of those maximums, isn't it? Part C. The lightest pineapple was also in crate 1. Is that true? Well, that's going to be the minimum, right? Is the minimum the lowest in crate 1? Nope. Look at that. That minimum is less. So no, it's not in crate 1. The lowest minimum is actually in crate 2. So this one's false. So C is not true. Next question, D. Crate 3 had the greatest median weight and the greatest IQR. Okay, well, let's take it one at a time. Let's compare the medians. I'm going to erase these so they're not in our way. The medians, if you remember, how do you identify the median on a box whisker plot? Well, the median is the bar in the center of the box. Or not the center, but inside the box, right? So the median is that line that's inside the box, okay? So does crate 3 have the greatest median weight? Well, crate 3's median is just over 4 pounds. Let's see, what do we think about crate 1? Ooh, crate 1 I think is slightly less than that. I think it's exactly 4 for crate 1. I think crate 3 is slightly more than that, and it's definitely more than 2. So I say yes for the median weight. Let's compare the IQR. Now remember, IQR is the size of the box. It's Q3 to Q1, right? It's that distance there, right? So does crate 3 have the greatest IQR or the biggest box? Oh, no, definitely not. This box is definitely smaller than this box. It's not the smallest, but it's not the biggest. It's not the greatest. So no, that one's a no. So does it have the greatest median and the greatest IQR? Since it had not the biggest IQR, that is false. Okay. So far, we only have 2 true answers. Let's see if there's any more. Part E, more than half the I'm going to erase this stuff so it's not in my way. More than half the pineapples in crate 1 and crate 3 were heavier than the heaviest pineapples in crate 2. Okay, well, the heaviest pineapple in crate 2 is right here at the max. So the heaviest in crate 2 is just under 3.5 pounds. So let's call it 3.4. Right? Well, and I called it 3.5 before, but I just realized it's slightly less than that, isn't it? Okay. More than half the pineapples in crate 1 and crate 3 were heavier. Well, remember, half is going to be either a whisker and part of a box or the whole box, right? So let's see. In crate 1, this would be half, right? Half the box and the whisker would be half. And that is more than that. So that's true in crate 1. But what about crate 3? Again, half would be this much. So yeah, look at that. They're both higher than the highest of crate 2. So that is true. So my answers for number 3 are A, B, and E. And there we have it, ladies and gentlemen. We are skipping number 4. So we are done with our very last practice problem set from Unit 8. And therefore the very last practice problem set for the school year. Congratulations, we are done with lesson 17. And you are now ready to take your very last Check Your Understanding quiz. I hope we get 100%er on this one. I'm feeling pretty pumped about it. So go ahead and get into Canvas. Take that last Check Your Understanding quiz. Do your very, very best on it because, as always,
do your best because you deserve your best.